This episode of Mathematics with Mr. Richardson is sponsored by 8 Lives Cat Food for the unlucky cat in your life. Remember, 8 lives. It has what cats crave. Let's consider a trinomial like x squared plus 3x plus 2. You've learned techniques for factoring a trinomial like this. Put a framework in place. Enter first terms that when multiplied equal x squared. Enter last terms that when multiplied equal 2 and when added equal 3. Insert proper plus or minus signs and then FOIL to check by multiplying first, outer, inner, and last. Section 8.6 asks, what if the leading coefficient of x squared is not 1? In cases like this, sometimes the polynomial will be factorable, sometimes it will not. But we'll learn strategies to factor polynomials with leading coefficients that are not 1. In section 8.6, factoring ax squared plus bx plus c. The objective of this section is to factor trinomials of the form ax squared plus bx equals c. An essential understanding for this section: you can write some trinomials of the form ax squared plus bx equals c as the product of two binomials. So another section with examples regarding solar panels. An array of 3 rectangular solar panels has an area of 3x squared plus 21x plus 36. The height of the array is x plus 3. What is the length of the array? Explain your reasoning. So once again we have an application problem, and once again we have a rectangle, and once again the dimensions of the rectangle are given to us as polynomial expressions. We have an area, we have a height, and we're asked to find the length. So we can very simply write the equation area equals height times length, replace area and height with the information we're given. To find this equation, we only have one variable remaining, length, our unknown quantity, and in order to solve for length or isolate the variable L in this equation, we need to divide both sides of the equation by x plus 3. So this would be a very traditional way to write this, dividing by x plus 3. However, if we can factor the polynomial on the left and factor out the binomial x plus 3, the value that x plus 3 is multiplied by would be the same as dividing the polynomial by x plus 3. So let's try that approach. So it comes to this. 3x squared plus 21x plus 36 equals the binomial x plus 3 times what? Well, as normal, we can substitute an x in place, but note, when we multiply our first terms, x times x, we wouldn't arrive at 3x squared as needed. So perhaps if we change the coefficient of the second x value from 1 to 3. That works. 3x times x is 3x squared, and now it's just a matter of finding the constant to fill in this place. Now we know that 3 times this constant, recall we call those our last terms, when multiplied need to have a product of 36. 3 times what is 36? 3 times 12 is 36. So we have a possible solution here. We should check by foiling first, outer, inner, and last. This is looking good. Combine like terms. And sure enough, we've arrived back at the trinomial that we were attempting to factor. Therefore, the solution, the Length of the array is the value that when multiplied by x plus 3 equals 3x squared plus 21x plus 36. And that's shown right here in our work. So the length of our array is 3x plus 12. So remember, the objective of this section is to factor trinomials that do not have a leading coefficient of 1. In this case, we have the trinomial 6x squared plus 23x plus 7. Notice its leading coefficient is 6. That complicates things just a bit over what we saw in the last section, but we'll learn some tips and techniques to deal with that. In this example, it's recommended to us to think of 23x as being 2x plus 21x. And that makes sense. We understand that 2x's plus 21 more x's equals 23x's. But what's so special about 2 and 21 that makes it helpful in this case? Why not use 10 and 13? Or 3 and 20? So let's take a look at what happens if we think of 23x as 2x plus 21. And then we'll take a little bit closer look at where those values 2x and 21x came from, and how you could arrive at those on your own. So 6x squared plus 23x plus 7 can be rewritten as 6x squared plus 2x plus 21x plus 7. We can then group 6x squared plus 2x and 21x plus 7. There we have two binomials at this point. Note that the binomial on the left has a greatest common factor of 2x, so 2x can be factored out of that binomial, as shown here. On the right, our greatest common factor is 7, right? 7 is a factor of 21x, also a factor of 7, so the 7 can be factored out and leaves us with this form. We can then use the distributive property in order to rewrite this as 2x plus 7 times 3x plus 1. And take note of how that was done. It's almost as though we have 2x's worth of 3x plus 1's, and we're adding 7 more of 3x plus 1's. So we would be left with 2x plus 7's worth of 3x plus 1's. And this is the factored form of our original trinomial. So I said earlier we'd learn why 2x plus 21x. Well, here's the thing to notice. 2 times 21 is 42. Considering our original trinomial, note that our value for a, our leading coefficient, that's also the coefficient of x squared, and our value for c, our constant in this trinomial, 7, 6 times 7 is also 42. That helps us to choose the values that have a sum of 23 and a product of 42. And that is what makes this process work out so nicely, and we arrive at the factored form. Example problem number 1. What is the factored form of 5x squared plus 11x plus 2? Well, following the book's examples, we can consider the factors of 10. Those are 1 and 10, and also 2 and 5. We're considering factors of 10 because 10 is the product of our values for a and c. 5 times 2 is 10. The factors of 10 again, 1 and 10, and 2 and 5. And now we consider the sum of those factors because we know that those factors must add up to 11 in order to give us the b value of 11, and 1 and 10. 1 and 10 will accomplish that task for us. So to proceed following this technique, here's how I would work. First, copy the problem. The trinomial is written here. Then, having considered those factors of 10 and finding the two whose sum is 11, proceed by writing this. Alright, keep in mind all that I've done is split the 11x into two terms, x plus 10x, and now group. Consider the greatest common factor of each of these binomials. And then consider that our binomial in each of these two terms is the same. If you get to this point and your binomials are not the same, you may need to rearrange the order in which you've written, in this case, x and 10x. Using the distributive property, and here we have the factored form. A quick check of our work using FOIL. Combining like terms. Gets us right back to the original trinomial, so our factored form is correct. Having examined that technique, here's something more of a brute force attack, where we will consider different options and try them until we find one that's correct. Now, the other technique, I think you'll agree, makes the work faster and more efficient for us. However, if you find yourself in a situation where you're asked to factor a trinomial of this form, and you cannot remember the strategy shown in problem number 1, then you may need to try this method. First, create the framework for the factored version. Consider the factors of 5. 5 and 1, and 1 and 5 because 5 is a prime number. Also keep in mind that -1 times -5 are also factors of 5. But for now, let's begin with 5 and 1. So we can confirm our first terms, when multiplied, do equal 5x squared. That's a good start. Now we need last terms, that when multiplied equal 2. Well, again, 2 is a prime number, so we consider 2 and 1. Well, perhaps the 2 should go in this position and the 1 in this position. If it turns out that is not the case, well, we can switch them and see what happens. Now, 11 is positive, 2 is positive, 5 is positive. It means we will not have any negative values, no minus signs in our binomials. Now, having plugged in these constants, let's check with a FOIL. First, x times 5x, 5x squared. Outer plus x, inner plus 10x. So I just kept track of that plus x in my head because I knew there'd be another term coming right up that could be combined with that. That results in a plus 11x. And finally, our last terms, 2 times 1 is 2. So this works. If this had not worked, as I said before, our alternative, or our second choice, would have been to swap the 2 and the 1 and give it another try with FOIL. In this case, it worked out really well the first time, but that is not always how it works. You may sometimes end up with a long list of factors, and you may have to try very many options before you find the one that works. So if you can remember the shortcut method shown to us in problem number 1, that will probably save you time and work. If you can't, a brute force method, checking all the factors, will still work. And your first chance to show that you have got it in this section. Part A, what is the factored form of 6x squared plus 13x plus 5? And part B, a reasoning question. In ax squared plus bx plus c, suppose ac is positive and b is negative. What do you know about the factors of AC? Explain. Example problem number 2. Factoring when AC is negative. What is the factored form of 3x squared plus 4x minus 15? Well, consider the factors of negative 45. Of course, recall, negative 45 is the product of 3 and negative 15, and here's a list of the factors. Next, consider the sums of those factors. We know that our target sum is 4, because 4 is the coefficient of x in our original trinomial. Having that information, we know that we can rewrite the trinomial and separate the term 4x into two terms, negative 5x and positive or plus 9x. To follow that up, we group these two binomials and factor out the greatest common factor. Once again, it should be noted that at this point your binomials should match. If they don't, there are a couple things to check. One, perhaps you didn't factor out the greatest common factor. Perhaps you'll find that one or both of your binomials can be factored further. And two, if your binomials don't match, perhaps you should change the order of, in this case, minus 5x and plus 9x. Using the distributive property once more, x plus 3 is the number of 3x minus 5's that we have in this expression. So there is our factored form. Of course, we can do a quick check. We've done this hard work. We're pretty efficient at foiling, so it makes good sense that we should FOIL to check our work. And we find combining like terms, we arrive back at the trinomial from which we started. Another opportunity to show that you have got it. What is the factored form of 10x squared plus 31x minus 14? Work carefully and make your selection from the choices below. Example problem 3, applying trinomial factoring. So now we have the skill of factoring trinomials with leading coefficients that are not 1, and we're going to apply it to a real type scenario. The area of a rectangle is 2x squared minus 13x minus 7. What are the possible dimensions of the rectangle? Use factoring. So once again, recall we know that the two lengths, or two different side lengths of a rectangle, often called its length and its width, or its height and length, when multiplied, have a product of our area. So we're just looking to factor this trinomial. This is just a fancy way to state factor the trinomial, but in a way that makes sense in a real-life context. So we would proceed through the process similarly, and since the process is so similar to the last two example problems, I won't work through this. It will save time on the video, but also the problem is worked here. If you're struggling to understand the concepts of factoring these types of trinomials, have a look. If you're feeling confident, move on. The next page will be the got it problem for this example problem number 3. And here is the got it problem. The area of a rectangle is 8x squared plus 22x plus 15. What are the possible dimensions of the rectangle? Use factoring. Work carefully and make your selection from the choices below. Just about the time we're feeling pretty good about factoring this type of trinomial, we could see one like this. 18x squared minus 33x plus 12. And then we try the techniques that we've learned, and we find that they don't work nicely. What we should notice, and this is a great thing to check when you begin factoring any polynomial, is that all three of these terms share a common factor. We should start by factoring out that greatest common factor. In this case, I notice 18x squared minus 33x plus 12, they don't share an x in common. However, 3 is a factor of all three of those terms. So we can factor out the 3 before we begin. Therefore, our expression becomes 3 times, and parentheses are very important here, 6x squared minus 11x plus 4. Then we set to work factoring the trinomial we find in parentheses using the techniques that we've learned. So considering the factors of 24, bear in mind 24 is the product of 6 and 4 from our trinomial, and finding which of those factors have a sum equal to negative 11, we find negative 3 and negative 8. We would then set up the problem by separating the minus 11x term into a minus 3x and a minus 8x term, and solve, much like the previous problems. One new thing to note is the 3, which we factored out in step 1, really just kind of hangs out on the left-hand side, away from all the factoring that's taking place inside the parentheses, and then it's there at the end of the problem. In this problem, we arrive at the solution, 3 times the binomial, 3x minus 4 times the binomial, 2x minus 1. So the greatest takeaway from this example problem 4 is always seek out a greatest common factor, and if you find one other than 1, factor it out before you begin factoring the value that's left in parentheses. And your final opportunity to show that you have got it in this section, what is the factored form of 8x squared minus 36x minus 20? Work carefully and make your selection from the choices below. And your first 2 lesson check exercises from the Do You Know How section. Questions 3 and 4 of the Lesson Checks Do You Know How section. And your final 3 questions, this time from the Do You Understand section of the Lesson Check.